All right, we are to the third and final lecture on stoichiometry, right? We started with just moles to moles and using our balanced chemical equation. And then we talked about moles and volume, or used our balanced chemical equation, but then also using our 22.4 number with liters. And finally, today we're going to be doing stoichiometry involving mass. And so we're not going to be using that liters number again. We're going to put that to the side. Okay, we're not going to be using our 6.02 times 10 to the 23rd number. No, no, no. We're going to be dealing with mass. So where do we get mass numbers from? Where is the only place in this class that we have ever gotten masses from? When we did molar mass, where did we get that info from? One place. It's a very, very useful place that we use often in chemistry. It's the periodic table. That's right. So we will be going back to our periodic tables. We'll be looking at the masses on there to help us solve these problems. Okay. So for all of our examples today, we're going to use the same basic equation here. 6 lithiums plus 1 nitrogen gas molecule. Remember, nitrogen is a diatomic. That's why it's N2. Makes 2 lithium nitrides. Okay. So one example of a problem you could see is if you got 1.75 moles of lithium nitride that are produced, what mass of nitrogen was there? Okay, so notice again, we're not just going moles to moles, so we can't, this is not a one-step problem. We're doing moles to mass, okay? So as it turns out, this is going to be a two-step problem, just like moles to volume was a two-step problem. Okay, so here we go. We're going to start with step number 1, moles to moles. Okay, we're going to start of moles with what we got to moles of what we want to get. So here's a moles of what we got, and we want to get to nitrogen. Now we want to get to the mass of nitrogen, but we can't go directly there. Okay, first we got to get moles of nitrogen, so that's what we're going to put it in our upper right-hand corner. And then what do we want to get rid of? Li3N, so that goes on the bottom. And now I go and I look up here and I see a 2 as a coefficient, so I'm going to put a 2 here. There's nothing written here, so that means there's an invisible 1 present, so a 1 goes there. And so now I'm going to solve. I'll do 1.75 times 1 divided by 2, which once you round that off to the hundredths gives you 0.88 moles of nitrogen. Great, that's the end of my step 1 problem. And so now I'm going to do step 2. So now in my second step, I'm going to finally get from moles of nitrogen to mass of nitrogen. Okay? So I'm going to start with what I just figured out, 0.88 moles of nitrogen. And then what do I want to get to? Mass, which is grams of nitrogen. So that's going to go in the upper right. Now what's going to go in the lower right? What I want to get rid of, moles of nitrogen. So here's where I look to my 1 mole of nitrogen. Here's where I look to my periodic table is 28.02 grams. How did I figure out? I got the molar mass. So I looked up on the periodic table, found that 1 nitrogen is 14.01. I multiplied that by 2 because it's N2. And so I got 28.02. So I put the molar mass on top. Okay, so notice I'm not using my balanced chemical equation here. I use that on the last step, my moles step. Whenever we're going to moles, we used our balanced chemical equation. But whenever we're talking about masses, we're using the molar mass. Okay, so then for my math here then, I'm going to do 0.88 times 28.02, and I'm going to get 24.66. And this should make sense because this is a little less than the molar mass, and 0.88 is a little less than 1. So like logically, the mental math works there. Okay, so that's how many grams I would produce. Okay, so that last example, we started with moles and we ended with grams. This time we're going to start with grams and end with moles. Okay, so we've got 49.04 grams of nitrogen, and we're going to figure out how many moles of lithium we need to react with that. So my first step here is not going to be using my balanced chemical equation because my balanced chemical equation can only go from moles to moles. And I don't start with moles, I start with grams. So I got to get these grams into moles first, okay? So that's going to be my first step. I'm going to figure out how many moles of nitrogen there are if there's 49.09 grams, okay? And so I'm going to be putting grams down here, and what number is going to go down there? The molar mass. Okay, here's the math if you'd forgotten, but we did it in the last problem. There it is, okay? And so basically I'm going to be dividing this number by this number to get 1.75 moles of nitrogen. Great, now I've got moles. And now for this next step, I can go from moles of my nitrogen to moles of my lithium using my balanced chemical equation. That's exactly what I'm going to do. Okay, so I'm going to put up here what I just figured out in my last problem, 1.75 moles of nitrogen. I'm going to put up here what I want to get to, moles of lithium. And what's going to go down here? Well, what do I need to cancel? moles of nitrogen, right? So I go and I look at my balanced chemical equation for my coefficients. I see an invisible 1 here, so a 1 goes here. I see a 6 in front of lithium, so a 6 goes here. So I'm essentially just going to be multiplying 1.75 times 6, and I'm going to get 10.5 moles of lithium. Great. That's what I wanted to know. All right, now for our last example. This one says if I have 25 grams of lithium, how many grams of lithium nitride am I going to make? Ooh, well, if grams to moles is a two-step problem, but I'm not going grams to mole, I'm going grams to grams. Oh my gosh, can you believe it? It's a three-step problem. Don't worry, it's going to be okay. So the first thing I'm going to do is I'm going to get my grams of lithium to my moles of lithium. Okay, so here's my grams, here's my moles. What's going to go down here? Well, I want grams to cancel, so I'm going to put grams down here. What's the only gram number I know for lithium? That's going to be the molar mass of lithium, okay? So this one's pretty easy. I just look it up on the periodic table and I see it's 6.94 grams, all right? So then when I do my division, I find out that that's 3.6 moles of lithium. Cool. Okay, now what? Well, eventually I want to get to this lithium nitride stuff. So my step 2 is now I'm going to do a mole to mole step to get from moles of lithium to moles of lithium nitride. Okay, so I got 3.6 moles of lithium. I want to figure out how many moles of lithium nitride that'll make. What's going to go down here? Well, this is what I want to cancel, so moles of lithium is going to go down here. I look for my coefficients. I see there's a 6 here, so I put a 6 here. I see there's a 2 here, so I put a 2 right there. And now I do 3.6 times 2 divided by 6, and that gives us 1.2 moles of lithium nitride. All right. And now lastly here, I want to get to grams. So can I get from moles to grams? I sure can. So for step 3, I'm going to convert from moles to mass. So I've got 1.2 moles of lithium nitride. I want to get to grams lithium nitride. Where do I get my gram information from? The periodic table, right? So I'm going to put moles on the bottom so it cancels. 1 mole is 34.83 grams, and here's me showing my work, how I got that. Lithium times 3 plus 1 nitrogen. That's how I got that 34.83 right there. That's the molar mass, okay? And so now I'm going to take that 1.2, I'm going to multiply it by 34.83, and that's going to get me 41.8 grams. So yeah, three-stepper. That as long as it gets. The longest problem you can have is a three-stepper, okay? So just to summarize, in stoichiometry, we've learned a couple different things, okay? We've learned that you can go from moles from one to moles to another, and that's a one-step problem, and you use coefficients from your balanced chemical equation. If you want to go from moles of one to volume of another, or volume of one to moles of another, this is going to be a two-step. You're going to use 22.4 for one step, and you're going to use your coefficients from your balanced equation for the other step. Okay, if you're going moles to mass or mass to moles, again, this is going to be two-step, and you're going to use the molar mass from the periodic table for one step, and you're going to use the coefficients from your balanced chemical equation for the other step. And then what if you're going to grams? That's going to be a three-stepper. Or, we haven't done this yet, but we will. What if you're going from volume to volume? Similarly, that's going to be a three-stepper too, okay? In all the three-step problems, your middle step is always a mole to mole, okay? So those are the different types of stoichiometry problems you could possibly come into. And don't worry, we will continue to practice this in class and also do some labs with it too.